Welcome to our perfect classes. In this video, I will discuss next part of artificial intelligence. I will continue previous topic, that is propositional logic. Propositional logic. We were looking at language of propositional logic while looking at the syntax of the language. We had seen in the last class that alphabet of propositional logic consists of two parts. In fact, alphabet of any language consists of two parts. One language part is a logical part, which is part say talking about domain essentially. In our case, since we are talking about propositional logic language, domain dependent part is basically a set of symbols which will stand for certain statements in domain essentially, and these symbols are atomic sentences. So when we look at language, we define this as a pair. We choose a set of connectives, and I said you can choose the subset of connectives and a set of formulas. You can say language that is equal to connectives, set of connectives, and set of formulas. And formulas will be represent to f, and their set is p, q, r. This is represent to p. Set of formula is chosen by first choosing a set of atomic formulas, then defining rest of language essentially. So let's call the set of formula f. We want to define what this set is essentially, and let's call this set of atomic formulas as p. This is represent to p, and that's given to us, that is the basic unit essentially. Now next I'm going to discuss about symbols. We have given, so this set f is defined as the structural recursion as follows. That's these two symbols, propositional constants that we had, they will belong to set of formula of a propositional language f. These two symbols represent to belongs to f formula. By definition they are always there, and then if anything belongs to set of atomic formulas, then that thing belongs to their set of formulas. So in other words, all atomic formulas are formulas, and all atomic symbols are formulas. So if alpha belongs to, if alpha belongs to set of formulas, belongs to set of formulas, then expression is not alpha. Then expression is not alpha. If anything belongs to anything belongs to set of atomic formulas, then this thing belongs to set of formulas. So in other words, all atomic formulas are formulas and all atomic symbols are symbol formulas. If alpha belongs to the set of formulas, then expression not alpha. If alpha belongs to set of formulas, then not alpha belongs to formula set of formulas. If alpha beta belongs to set of formulas, then you can say alpha and beta belongs to formula, alpha or beta belongs to formula, alpha implies beta also belongs to formula. And here this is a set of sentences in our language. And you should keep in mind that sentences should be truth, values, atomic sentences, formulas, semantics of connectives. V colon P implies true, comma, false. V means here value. If if alpha is equal to true, it means alpha is true, value of alpha is equal to true. If alpha equal to true, then not alpha is equal to false. For example, you have given alpha you have given alpha, that is true and false. And not alpha means true, false, false, true. Now, for example, you have given two values, alpha and beta. True, false, true, false. True, true, false, false. If you want to calculate alpha and beta, then you should keep in mind that both conditions should be true, and otherwise false. If you found two alpha or beta, you should keep in mind that either one of two conditions should be true, then result will be true, otherwise false. In both cases, if they are false, then result will be false. Both true, true result. True, false, true. False, true, true. False, false, false. If you want to find alpha implies beta, then you should keep in mind that both true, true, false, true, true, false, false, true, but true, false, false. And in case of exclusive or, that is represented by this symbol. In this case, if both are true, then false, both are false, then false. Otherwise, true. This is called exclusive or, and this is called inclusive or. For example, if you want to calculate equivalence, then both are true, true, both are false, true, otherwise false, false. This is the equivalence. Not alpha exclusive beta, that should be equal to alpha in alpha equivalence beta. Alpha implies beta, that should be equal to not alpha or beta. This is a truth table. If you find, you can write implies symbol like this. You can also use this instead of this symbol, and it is equal to alpha change into not alpha, and this symbol change into or beta. Alpha and beta, that should be equal to not of not alpha and beta, and that is equal to not of not alpha or not beta. Here we use not and or connectivities. Now, next is a next point you should keep in mind that semantics, if alpha is true and beta is true, then you can say alpha and beta equal to true, else alpha and beta is equal to false. If p is equal to true, Q is equal to false, and R is equal to true. It means Q implies R or R implies P. That is equal to R or true. R or true. Hmm. How to solve it? We can solve like this: P, Q, R. True, false, true, false, true, false. 2, 4, 6, false. 2, 4, 6, 8. Double T, double F, double T, double F. 4 time T, 4 time F. First we have to find Q implies R. Both are true, true. True, false, false. False, true, true. False, false, true. True, true, true. True, false, false. False, true, true. False, false, true. Then find R implies P. True, true, true. False, true, true. True, true, true. False, true, true. False, true, false, false. False, false, true. True, false, false. False, false, true. Now take OR of both. True, 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 true. This is a tautology. And on the other side, R or Q. Here is not T, not Q. R or Q. True, 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 and true. You can say that both are equal to. Thus, we find these are equal to. Or another way, you can solve it like this: Q implies R or R implies P, not Q or R, or not R or P. This one, finish this one, not Q or P. And when we find P in not Q or P, you will find same answer. You can check. Not Q. False, false, true, true. False, false, true, true. True, 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 true. False, 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 false. And or true, 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 true. False, 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 so true. This one true. Mm, you, you you can't do like this. You have to make a table and prove that. Now next points you should keep in mind: truth values. Truth values, three kinds of formulas make up false. And tautologies. Tautologies true, independent of valuation function. And tautologies will be found when all values are true. Contradictions or unsatisfiable. Contradiction, unsatisfiable. Always false. And contingents, in case contingency, true or false both. Means true in some cases and false in some cases. And contingency satisfiable. Thank you. I will continue next part in next videos. Don't be forget to subscribe my channel for next upcoming videos.